Hello everyone. In this video, I'm going to answer for you a question on differentiation. The question is straightforward. You have a curve y equal x cubed plus 6x squared plus 5, and he wants to find the dy by dx, or the derivative of y with respect to x. So we just remember the rule together. If we have dy, if we have y equal to x power n, this gives me dy by dx is bring the power down n and then reduce the power of the x, nx minus 1. If we have y to the power x to the power n, but if a coefficient is multiplied to it, the coefficient remains the same, dy by dx. The coefficient remains the same, and then we apply the same rule, which is bring the power down and then reduce the power of x. If we have a constant, if y equal a constant, a, for example, then the differentiation is equal to 0. Now, if we go back to our function, dy by dx, we have x to the power 3. This is the first rule. So the differentiation is 3x squared plus 6x squared. The differentiation of 6x squared is the second rule. So the 6 remains as it is, 6, and then we bring the power down. So it becomes 6 times 2 and reduce the power of x. 2 minus 1 is 1, so x to the power 1. Plus differentiation of a constant is 0. Now, if we want to simplify this, this becomes 3x squared plus 12x. Now this is solved. 3x squared plus 12x. So we have the first part of the question is answered. Now we go to the second part. The second part says that the curve x cubed plus 6x squared plus 5, which is the same as part A, has two turning points. And he wants to know the coordinates of those turning points. So the turning points, we have the turning points. They are either a maximum and a minimum, and they are the points where the slope or the gradient of the curve is 0. So dy by dx is equal to 0 at those points. Now, we also have to remember that this is a cubic function. So a cubic function has two turning points, a maximum and a minimum. We also have to remember that if the coefficient of x cubed is positive, this means that the maximum occurs before minimum. It means something in this shape. If you want to draw this, it's going to be something like this. Okay, where the maximum occurs before the minimum. Now, particularly, he doesn't want to know the nature of those two turning points. He was just asking for the coordinates. So we are going to let dy by dx equal to 0. So dy by dx, we got it from the first step, 3x squared plus 12x. This is a quadratic equation with the term c equal to 0. So the easiest way to solve here is to factorize. So we take 3 as a common factor and x as a common factor. So this becomes 3x open bracket x plus 4. This is equal to 0. So the solution, we have two solutions here. Either x1 is equal to 0 or x2 is equal to -4. If we substitute in the curve by x equals 0, this gives y equal 5. So the first point is 0 and 5. The second point is if we put -4 in the curve y, then we get y2 is equal to 37. Now this is the answer. So we have the maximum at -4 and 37 and the minimum at 0 and 5. Why the maximum at -4 and 37? Because this is the point before 0 and 5. We said that the maximum will occur before the minimum because the curve has a positive coefficient for the x cube. If we want to draw this curve accurately, it is something in this shape. We are going to have at -4 and 37. We are going to have a maximum here at this point, and the minimum at 0 and 5. So 0, x equals 0. And let's say this is y equal 5. So the curve is going to be something like this. All of this is not required in the question. What was required is just the coordinates of those two turning points, which is the solution of the quadratic equation, and substitute by the x in the turning point of the curve and not in the derivative dy by dx. Like this, the problem is solved. I hope you like this video. Please don't forget to like and share. Also, let me know your comments, and I will be happy to answer them. Thank you, and have a nice day. Bye-bye.